Hello students, this is Abdelkader Ouda. Welcome to AS 1036 video series. In this video, we are going to talk about inheritance. Inheritance is a capability that is provided by object-oriented programming language such as Java, and it gives you the ability to create a class that is represent an object that is a specialized version of more general object. To understand what this means, let us look at how we can use inheritance through a real-world example. Assume that you were among a team of programmers who developed a human resources management system, HRMS. And your task was to develop a class to maintain some information for a person. For instance, you developed this class, a class person, and you defined these 4 attributes to store the information about first name, last name, year of birth, and the address of the person. In addition, you defined a set of setters and getters to set the first name, last name, and set the year of birth, set the address, and return the name and the age of the person, in addition to show the address in a map. And you defined or you override the toString method in order to display the information about the instance of this class person. Okay, so let us look how did you develop this class using a Java program. Here in the screen you see that we have a class person, and we have here the 4 private fields, and we have the setter and getters. It's just straightforward as you did this task a number of times before. And we have here the get age. In this method I used local date Java class in order to be able to retrieve the current year value. So this is, you can assume that this is outside the scope of our course content, but just for your knowledge, there is a way that we can use the class local date in order to get the value for the current year, and then we deduct the value for the year of birth from the current year in order to get the value of the age. You did something similar to this during the midterm exam, but I ask you to assume the fixed value 2020 for your calculations. All right, and here for the show address, I don't need to go through other libraries to show a map like Google Map and then show the current location in the map. So again, this is outside the scope of our course. So I just return here, instead of returning the URL of this map, I'm just returning the string currently not available. And I override here the toString method in order to form a string and turn it to the caller in order to display the name and then the first name, last name, and then in the new line we print the age. Good, so now I have a complete implementation for the person class, and now we need to test this class. So I'm going to show you here a new way that you can test your class without the need to write a demo class. So simply we can write here the main method, and inside this method we can test this class. So I write here the main, and then to use a shortcut from the IDE, I hit tab. This will create the header for the main method. Inside the main method, I will create an instance of this class and then start to test the setter and getter method. So I'm going to use the class person. In this line here, I created an object called someone of type person, and now I'm going to use this object to test the setter and getters. In these new 3 lines, I used the object someone, and I set a value for the first name John, and the value for the last name Do, and then the value for the year of birth 2002. Now I'm going to test the toString methods that use the get method as well. So I'm going to use system.out.println to print the information of this object. So here I just used the object name through the system.out.println line, and you know that when we mention the object name in an expression to be printed, the toString method will be invoked automatically for us, and then we're going to return this string, and this string will be printed here. Let us go ahead and run these codes. You can see that here it compiled successfully, and it displayed here name John Doe and the age 18. So this is a new way that you can test any class you developed without the need to create another class to have the main method. You can simply add the main method at any part of this class in order to test it. Good. So far you have created this class person, and you were able to successfully implement it in Java code. So let us assume now that you joined another team of programmers who are developing a clinic information system, CIS, and you have been asked to develop a class to maintain information for doctors and another class for patient. So you started immediately and you defined this class using the UML class diagram. So you defined here again first name, last name, year of birth, address, and you added the specialty for the doctor. In addition, you defined a set of setters and getters to set the name and the address, and get the name and the age, and also to set the specialty and get the specialty of the doctor. And also you need to override the toString. And you also defined another class for the patient, and also for the patient you need to maintain the information about the first name, last name, year of birth, address, and also you need to maintain information specific for the patient about the admission date to the clinic and the discharge date, in addition to the set of setters and getters to set the value for these fields and to get their values. And at the same time you define the toString method in order to display or to return a string maintain the information of this patient. Notice that here you have when you develop these two classes, you have some duplication of the code. You have here the first four fields in the doctor class are the same of the first four fields of the patient class. Also, you see that here all the set methods the same as the set method for these two classes, and you have some method here specific for the doctor class and another method here specific for the patient class, like set admission or set discharge date. Remember, in your previous task you develop a class for a person, and inside this class you also maintain information about the first name, last name, year of birth, and address. Exactly the same thing for the patient and the same thing for the doctor. Same as for the setter and getter method. You notice that here you did some duplication in the code. This is called duplicate code, and as best practices or as a good programmer you need to avoid duplicate your code among number of classes. So why we need to add these fields and these methods while we already have them defined in the person class, and we implemented successfully and we just tested and running perfectly? Why do we need to duplicate the code? So what we need to do is to try to reuse the code that we implemented already and we tested and declare robust. So this is called code reuse. So instead of defined here first name, last name, year of birth, address, no need to define them here again in the patient class, and also no need to define these setters methods and these get methods. Likewise for the doctors, you don't need to redefine first name, last name, year of birth, address, and also we don't need to define these setters method and getter methods because we already have them in the person class, and our attempt is to reuse them again for the patient and for doctor. So as you can see here, we have in the person class some characteristic like first name, last name, year of birth, and address. And the patient class has the same characteristic of the person, in addition to some specific information like admission date and discharge date. For a doctor, also share the same characteristic of a person, in addition to some specific field for specialty for the doctor, and also share the same operation for the general operation for the person, in addition to some specific operation, set specialty and get specialty. So how can we reuse the code that we implemented already in the person class and use it in patient and use it in the doctor class without the need to duplicate them again? So this is the purpose for inheritance relationship between classes. So let me show you how can we do this. So I need to show you here how can we reuse the code for the class person through the class inheritance. So I added here the class person, and I revised the class doctor and the class patient, and I removed all the duplication from both classes. Notice that here the class person contains those attributes and methods that are shared by all persons, and the class doctor contains now those attributes and methods that are specific to a doctor, and the class patient contains those attributes and methods that are specific to a patient class. Now, how can we inherit, or how can we reuse these four attributes for the class person inside the class doctor? How can we go to reuse these four fields in the person class inside the patient class? This is here the purpose for inheritance. So the class doctor is going to inherit from the class person, and this is the way how can we represent such inheritance using the UML notation. I write it here, the unfilled arrowheads that is linked from the doctor class pointing to the person class, and this relation now is called is a. So now I can read it, doctor is a person. So this notation here shows that the class doctor is going to inherit from the class person. Same thing here, I need to do the same relationship between patient and class person. So we have an arrow from the class patient attached to the class person with this unfilled arrowhead. And again, this is a relationship, and we read it that way: patient is a person, or patient is a kind of a person. And now this line telling us that the class patient is going to inherit from the class person. By having this inheritance, we can say that the doctor class contains those attributes and methods that are shared by person, in addition to those attributes and methods that are specific to doctor. And here inside the patient class, we're going to have those attributes and methods that are shared by a person class, in addition to those attributes and methods that are specific to the patient class. So now we call this person class as a superclass, and the doctor class and the patient class as subclasses. So we may call them a superclass, and also we can call them a parent class, and we call the doctor class as child class, or we may also call it as a base class. So person may call it as a superclass, or parent class, or a base class, and in this case the doctor class can be called as subclass, child class, or derived class. Good, so I'm going to stop here, and I'm going to show you another video how to implement the inheritance and this UML class diagram using Java.